In software engineering, we are discussing chapter number 23, the testing conventional applications. MBT or model-based testing. First, let me tell you, this model-based testing is a black box testing. And here it uses the requirement model for the test case generation. So you don't need to go into the detail of the structure part or the internal part of a software. The requirement model is the basis. So the MBT, it employs the UML state diagrams. Under these requirement modeling, we have made certain state diagrams, use case diagrams, sequence diagram. So we will use the state diagram for making the model-based testing or doing the model-based testing, because this is the element of a behavioral model. So here, because the name is suggesting, we will create models. We will not do the actual thing. For example, if this is, say, a website and you are clicking somewhere, say add to cart, some other buttons should come up. So we have to model it, that when we click that other button, what will happen to the previous button. So these are the models, that is in the web page, for example, which page we are going, in which page, which section a user can go, where he can navigate. Maybe he can go from 1 to say 3, 1 to 2 different pages he can go, which section he is going to go. So this needs to be modeled, and that can be done using the behavioral model, which is the state diagrams. So model-based testing requires 5 major steps, because this involves creating also. That is, we will analyze an existing behavioral model. If this behavioral model is there, it is okay. Otherwise, you need to create a behavioral model in order to do the model-based testing. Because behavioral model is what? It indicates how your software is going to respond or act when an external event or a stimuli or a stimulus is there. That is, some software is given. Basically, we are trying to talk about the event driven. Some events, some stimulus. We have already discussed how to create these behavioral model. But let me give you a brief hint. Evaluate all the use cases just to understand the sequence of interaction within the system. First, use case is the basis. Then the interaction you have to understand, and identifying the events that drive the interaction sequence, and understand how these events relate to specific objects. That is, how the interaction is going on, which event is producing what. Then we have to create a sequence for each of these use cases. Use cases, that is the requirement. So now you have to build a UML, that is a unified modeling language state diagram for the whole system, understanding the point 1, 2, 3. And this state diagram, once you have made, you have to review the behavioral model for accuracy and consistency also. This behavioral model will be the basis of model-based testing. The second step is what? Because already we have made behavioral model. So this already we have made, and as I said, the state diagram is the basis. So this state diagram, we have to traverse this behavioral model, and then we have to specify the inputs that will change the software from state to state or transit it from state to state. Then we have to review the behavioral model, and then we have to see what are the expected result. For example, the state is changing, A is 1, A becomes 2. So we have to note the expected outputs. For each set of inputs, that is the test cases which are specified in the step 2, we have to specify the expected outputs as in the behavioral model. Then we have to do it, means actually execute the test cases. This can be done manually, or we can use the test script. and we can use the testings too. Main thing is we have to see the expected result and the actual result. If there is some non-correspondence, corrective action is required. So MBT is uncovering the errors of behavior, software behavior. So as I said, MBT is extremely useful where the event-driven application is the main context. In any software development life cycle or software processes, there are various work products being produced. Normally, we relate the testing with coding. But we were doing the black box testing, white box testing. We learned so many aspects of these two testing. Okay. But there are certain more work product like the documentation, requirement specification, the software design, the user manual, the compilation guide. So these are all also deliverables. Now this is the duty of the software team to also test the documentation, all the documentation along with the user manual, help facilities, installation guide, compilation guide. There are so many different work product or the documentation generated as a result of all these software processes. Okay. So user manual, user guide or customer guide, as I said, they are different product, different results of documentation will be there. So what happens if you are as a user using a user guide or a manual or say an online help and it is not helping you? It is just there and not being properly made. It will be so frustrating for you as a user. So for every software test plan, documentation testing is a must. We just don't think about documentation testing, but it is integral part. So documentation testing normally happens in two phases. The first is the technical review. That is, a person will sit, he will see the editorial clarity, semicolon is not there, the sentences are not properly formed, or they are ambiguous, or they are not pointing to what we were wanting. For any novice user, it should help. And the live test, that means using the documentation in conjunction, in help with the actual program. For example, you created an installation guide or you created a user manual. Now we will start with the installation guide and we'll try to install the software. Or with the user manual, we will try to do certain activity or achieve certain functionality. Okay, but if you are using it and if you are stuck somewhere and this user manual is not helping, that means the testing is the main criteria to find out these are the errors. For this, that you have to do testing. So live test for documentation, this may use certain techniques which are very similar to black box testing. For example, if the usage of the program, use of certain functionality has to be tested, graph-based testing method can be used. For input, classes of input and their interaction, we can use the equivalence partitioning or the boundary value analysis technique. This can be a help. Okay. So graph-based testing, equivalence partitioning and boundary value analysis, depending upon what exactly documentation part you are going to see. MBT, you can use model-based testing to ensure document behavior and what is the actual behavior of the software. Does it coincide or there is non-correspondence? So please understand, testing documentation is as important as testing your code. Testing for a real-time systems. First, you have to understand what are real-time systems. Real-time systems are all those systems where the time is critical. Something has to happen in the prescribed time limit. The time constraint is rigid. If something has to happen in 1 millisecond, it has to happen in 1 millisecond. Okay? For example, in flight system, in those systems where the life is involved, Okay, for train system like say defense armaments. So here you see, if you microwave you're using 30 seconds you input, and after 30 seconds what happens? Microwave stops itself. And in this 30 seconds, you have pressed some button, but sometimes you can press another button, you can open the lid or open the door. These are interrupts. So most important thing in real-time system are interrupt. Interrupt are those which want attention. So it can be preemptive, it can be non-preemptive. Sometimes the interrupts are so important like trap, they have to be accepted. Sometimes the real-time systems may say postpone attending the interrupt. For example, CPU. There are certain times the CPU will work and will wait for actually acknowledging the interrupt. Otherwise, some interrupt it has to acknowledge by stopping its work. So there are real-time systems, soft, hard real-time systems. So there are two partitions, hard and soft. Soft real-time systems like all the operating system which are RTOS, that is, they want certain time limit, this has to happen, but if it doesn't happen, there is not much of a concern. Hard real-time system, it is much of a concern, it can be catastrophic. So the time dependent asynchronous nature of real-time application adds a new element to the testing, which is time. Asynchronous because anything can come at any time. Time is important. So the test case designer, he will use all the conventional test cases, but he has to understand and consider the event handling, as I am saying, like the interrupt processing, timing of the data, and the tasks are going, say, parallel. So parallelism of the tasks or the processes have to be dealt with. So test data for the real-time system in one state may result in proper processing. For example, test data at state 1. But the same test data for different state of this real-time system may lead to an error. This has to be checked and verified. Let me tell you that again, why it is difficult to test the real-time system. Time constraints are there, conventional methods cannot be used directly, and you can get some unpredictable outcomes. For instance, just take the example of this photocopier machine. Now this has a hardware and a software combined. So we can call it as a real-time system. So there are certain control keys. The real-time software that controls a new photocopier, it can accept operator inputs. That is, a user or a machine operator can hit a reset or darken with no error when the machine is making copies, everything is going good. But the same operator interrupts, same pressing of the button when the machine is not copying state, but it is somewhat jammed. The paper is inside, it is jammed. Now it can give you some other result, or it can give you some diagnostic code. Where is the jam? What is the location of the jam, cause of the jam? That is the error. Okay. So copying state, things can go fine. But what about the jam state? So there can be some code like error 003. I'm taking just an example. So software test must consider the impact of these hardware faults on the software processing, because now real-time system is a combination of a hardware and a software. So it's a combined combination. So if some hardware failure is there, you have to consider that also. So there are certain strategies. We are going to discuss a 4-step strategy for real-time software testing. First is the task testing. There are different tasks. Test for each task has to be done independently. You can always do the conventional task testing because you will see the logic, errors in the logic and the function. But the timing and behavior cannot be found here. You cannot uncover errors in timing and behavior. For that, you have to go for behavioral testing. And you can use certain models which can be created by automated tools, or even you want to create it, you can create it. You can simulate the behavior of the real-time system, and then you can determine or examine its behavior as a consequence of some stimulus or external events. First thing in behavioral testing is you can use these state diagrams, or you can, automated tools are there, you can create your own model. So like the equivalence partitioning, these events which can be interrupts, it can be some control signals, you can also categorize them for testing into equivalence classes, and then you can use one of them and test it. So how to do this in behavioral testing? For instance, in a photocopier only, the events for the photocopier, the user might have the interrupts like the reset counter, or there can be some mechanical interrupts from inside coming, like the paper is being jammed, or some system interrupt, oh the toner is low, the ink is low, this can come, and some roller is overheated, so this is some failure modes. So all these events, each of these events, these needs to be tested individually, and that can be done using the behavioral testing. Okay. What is the third one? Inter-task testing. See, once there is an error in individual tasks and system behavior, these are errors you have isolated, you have found and say done something for them. Now our testing will shift to the time related errors, because this is a real-time system. So there can be tasks which can communicate at any time. These are asynchronous tasks. When they are communicating or talking to one another, you have to test them with different parameters. For example, the data rates, the processing load for this inter-task, whether there is some synchronization errors in these tasks. Let me tell you, we have already done for the two-step individual task, we have checked, system behavior we have checked. I am talking about the inter-task testing, that is different data rates you can change, the processing load, and there can be other parameters also, and that can give you this synchronization error. Now let me give you an idea. If the communication is happening using a message queue or a data store is there, that is from task 2, first thing goes to message queue, then goes to the task 1, or a data store is in between, then you can change the size of this data store, message queue, you can change or shorten or make the size more, then you see what errors are coming. The fourth is the system testing. The software and hardware are integrated, and then the system tests are conducted, because we need to know the interfacing errors. What are the interface errors? Since the real-time systems, they are processing the interrupts, so testing the handling of these Boolean events, 0, 1, yes, no, you have to do it or not, is quite essential, because in the system testing is an integral part. So as I am saying, the state diagram, using these which have already been made in the requirement modeling, tester would develop all the possible interrupts and what is the processing. So tests are designed to assess. There are certain system characteristics when you are doing system characteristics, like are the interrupt priorities properly assigned, and are these interrupt properly handled with proper priorities? Is processing of each interrupt handled correctly? And then, because these two are important, then we have to see the performance also. Does the performance of processing time of each interrupt handling procedure conform to the requirements? Is it happening in time or it is exceeding it? Does a high volume of interrupts, because multiple interrupts can come, does a high volume of interrupts arriving at very critical times, that may create a system to dysfunction or the performance issue is there? Okay, this is all about this discussion today. Thank you so much.